Okay, let's just solve some wave equation problems here. So let's start with number 15. I always read through a question the first time and see if I can figure. I look for the interrogative word. Here we go, how. All right, and what it says is how many times a second does the sound wave cost? So how many times a second, that's frequency. So I know, let me just go ahead and color that and say, okay, I know that what I am looking for is the frequency. This is what I'm trying to find. So what I'm going to do then is I'm going to see what other information I have. So what I've got here is meters. Meters measures the wavelength of the wave. And then I also have, let's see, what else do I have here? I have meters per second. Meters per second is a measurement of the velocity of a wave. So what I have then is I'm just going to go ahead and I'm going to divide the velocity by the wavelength to solve this equation. So what I have then is 330 meters per second divided by a wave that is 1.29 meters long, and that equals 255 hertz, which happens to be what the C note on a piano is. Alright, let's try number 16. Alright, so KNDD, a radio station you may listen to, it broadcasts at a frequency of 107.7 megahertz, which means million hertz. So that basically means the base frequency for those waves, it has electrons in the tower wiggling 107.7 million times a second, which is kind of a mind blower. Now, radio waves, like other forms of electromagnetic radiation, travel at the speed of light, which is 3 times 10 to the 8th meters per second. Meters per second, that's a velocity. Hertz, that's a frequency. And when I look for the interrogative word, how long are the waves? I'm looking for wavelength. So what I'm going to do is I'm going to divide the velocity by the frequency. So in this case, my velocity is 3 times 10 to the 8th meters per second divided by a very high frequency wave, 107700000. And when I divide these two big numbers by each other, I get a very reasonable 2.78 meters. 2.78 meters. That is the length of the radio waves made by the station. And by the way, they have to be passing through your body this very second, and your body is transparent to them, and I happen to think that's pretty wild.